Three, two, one, and we're live. Well, here we go, the first episode of 345 Tech Talks. What we've got today as a subject is tracing and debugging microservices and Kubernetes. So we're not messing about, we're going deep today. We're not picking an easy topic, we're picking something really, really deep because it's actually an important topic. The reason why we've picked this topic is actually on our website. And let me just see if we can share this. On our website, our best ever, most viewed article is best practices for tracing and debugging microservices. That's the one that's had the most hits out of all the articles we've ever done on our website. And so it seemed to be an ideal topic to have a chat about because, first of all, we know people are interested in this. You know, microservices are a big thing. Kubernetes is now a big thing. Containerized apps are a big thing. And we've been doing some really good work in that area. So it seemed a really appropriate thing to do for us to start talking about that. So on the call today, we've got Paul Brown, Chief Engineer and CTO of Glue, and the co-owner of 345. So Paul's got a wealth of experience in all things to do with building massive systems and building them really well. And you know, in all sorts of areas, you know, pharmaceuticals, financial services, banking, just big stuff that's mission critical, regulated, high quality, can't go down ever type of stuff.
Or you don't want it to go down ever, right?
Or you don't want it to go down.
That's not the intention. Yeah.
More to the point,
Yeah.
I'm Andrew. I'm CEO of Glue and co-owner of 345 as well. So, and just to fill in a little bit of what that is, with Glue, we're building a cryptocurrency, world-changing cryptocurrency application. It's sort of a TripAdvisor meets Amazon meets a bunch of fireworks, and that's what we're building. It's going to be launched later this year, and we're really excited about it. And the stuff that we're working on in terms of technology is the stuff we're going to talk about in our tech talks. So the content of what we're talking about today is really what we're working on right now. So it's not as if we're not theorizing about this stuff. This is what is in build right now. That's fair enough, isn't it, Paul?
It is, yeah. I mean, it's relatively early days, but yeah, we are building out the stack, as we say, and obviously, one of the core planks of that is tracing and logging. Yeah, it's so fundamental that it's almost one of the first things you think about when you're building an application.
Cool. One other thing before we start, well, there's a couple of things. First thing is, as we know in technology, there are a few things more important than coffee. So yeah. I hope you got yours sorted.
I'm not actually sure about that, but yeah.
So at 345, we developed a holistic approach to software with and one of the things we focus on is what we call the 7 outcomes. So these are the signs of success. So if we think that you've got success in these 7 areas, then pretty much your software development is pretty good. And the 7 outcomes, as we see it, are: number 1, rapid delivery; number 2, that it's high quality, bug free software; number 3, available and scalable. So which is a lot of your non-functionals. Number 4 is secure, obviously. Number 5, functional and lovable. Number 6 is that cost optimized, and that covers both operational costs and development costs. And the 7th one is that standards compliant, that you're meeting all the external needs that you need to meet. So with Kubernetes, one of the reasons why people choose Kubernetes is because they want rapid delivery, and they want the kind of the availability and scalability that comes with making clusters and deploying applications into them. And also, it is cost optimized. You can get very dense deployments of applications while still making them very available. So those are the so out of our 7 outcomes, those are the main things that people are looking at with Kubernetes. So on that note, I think we've kind of teed this up. I think we've teed this up enough so we can probably just start shooting the breeze on that a little bit. So
Okay.
talk about why, tracing, debugging, instrumenting, logging, you just touched on it then. Why is it so important?
Well, imagine. So if we forget about big systems where you have many services, many ways of interacting with an application, you can imagine the complexity of a distributed system. And if things go wrong, how do you figure out what's actually happened? But if you just go down to a simple desktop application and something happens and you get the dreaded error, like an error has occurred, and you're
Yeah.
like,
Contact your system administrator.
what? Or contact your system administrator. Yeah, you get that a lot. Oh, well, you used to get that a lot. And you think, well, what's happened? If the application itself is not logging, how do you figure out that maybe there was a file permission issue, or maybe there was a missing file? It's something actually you could easily figure out yourself, but you can't. So you end up on Google and you're trying to find out if anybody else has had any problems, and all through some innocuous error message that you receive. So if you had an easy to read log file, then actually it would probably make your life a little bit easier. Depending on the level of the end user, right? Some people probably will be able to figure out what's going on in the log file, but at least a log file gives you some idea as to what's happened.
And at least at the very least, if you've got an application, you can send that log file to someone to diagnose as well. Even if you aren't looking at it yourself, you can still send it to someone.
Absolutely. So you could go to the manufacturer of the application and say, look, here's the log file. Can you tell me what's wrong? At least they've also got some idea. They can't see what's going on your machine. So it's at the very least there's some information that allows them to try and diagnose the issue. And then you scale that up. So now you've got a system running in the cloud. It's black box. It's running, tens, if not hundreds, of different services. Those services are integrated with each other, so it's going over networks. And something fails, and
then it's like needle in a haystack, isn't it?
Without logging, I mean, without fundamentally logging within the service itself, it's pretty much impossible to try and figure out what's going wrong. But then you've got the wider issue of, well, actually now I've got hundreds of services. So it's great that I can log from one service, but how do I get those logs in order to make it easy for me, who's remote from the cloud, to be able to actually figure out, is that service that failed, get the logs for that service so I can actually diagnose it.
Is there a difference between sort of doing this sort of at development time, design development, and doing this at runtime with your operations? Is there any difference in how you approach that, or when it's cloud, it's just that's pretty much all the same thing?
No, not well. I wouldn't say necessarily. Obviously, Blackbox Systems have their own challenges, right? So you have to think about how do I get information out, diagnostic type information out of the system. So you have to start thinking about tools and technologies that make it very easy for you to be able to effectively collect all those logs and bring them into an environment that makes it easy for you to search through them. The fundamentals of when you're developing a service and whether it's whether you're building one client server app or one desktop app or a fully distributed system with hundreds of services, those individual components still need to log. So you don't. So in terms of the way that you approach tracing, you don't generally really approach it any differently. Whether you're building a desktop app to whether you're building a distributed system, they're all individual components that need to log.
because it used to be, and this is kind of, it was a good thing, but also led to a bad thing, and that is that you could attach a debugger onto an application,
Yes.
and so developers could step through their code, find where something was going wrong, and and diagnose it by stepping through the debugger, which might have which was really really useful, but at the same time it might have led them to sort of think that they could get away without the level of logging, which meant that when you're in production you probably get less information than you need. So
True.
So actually now going to more of this sort of distributed stuff where we're actually logging probably means that if you use that for development and for runtime, it probably forces you to do the right things for runtime.
So if you think about, so it's a really good point actually. So if you think about debugging, so debugging a single-threaded app actually is, assuming you got the debugger right, so and you got the environment in which the debugger can work. I mean, debugging a single-threaded app is quite easy, and you can reason about it. You can understand what's going on because it's only going to be doing one thing at any one time.
Yeah.
If you think about a multi-threaded app,
asynchronous
and there's all sorts of asynchronous functions firing off all over the place. I mean, it's a mini distributed system, right? So it's still the same challenge. So unless you've got a sophisticated debugger that can allow you to debug across threads, switch between threads, that actually becomes quite difficult. Plus, when you create multi-threaded applications, timing becomes all important. And you can end up in all sorts of race conditions. But debugging can often so if you're attaching the debugger, it can often mask issues that are timing related.
And also, like, debuggers slow down an application
because they're slowing down, and therefore
so that sometimes race conditions either don't happen when you're debugging, and then you let the full force go, and then it's suddenly you get these issues.
Exactly that. So, I mean, you go back to earlier programming, right? Before we got really sophisticated with distributed systems, because network became quicker, right? So, but if you go all the way back, printf debugging, right? So if you're writing in C,
that's a bit before my time. Bit before my time, mate.
Exactly. Well, okay, fair enough. Unfortunately, not before mine. But yeah, printf debugging, right? Console out.
Yeah.
It's the age-old way of debugging programs, and it's not gone away. I mean, yes, it's great having debuggers, fantastic. But sometimes the old way is always the best, particularly when you have lots of independent services. You need to be able to at the very least log at an individual component level. Then you have the challenges of okay, so normally in a distributed system, you never normally just use one component. Normally it's a series of components called one after another.
Yeah.
So then how do you reason about that flow? How do you make sense of that flow when each individual component is logging, but you actually really need to understand the full end-to-end of the request that's being made or the action that's happening, and that in itself is another problem than tracing and debugging at a single component level.
Okay, which kind of leads us, is a nice sort of segue into the next thing, which is to see, because what we're talking about really today is, so here's the problem of tracing and debugging, and then microservices, containerized, running in Kubernetes. So the first thing is, we've got a little bit about, how does, and I think this is where you're getting to, is really what is microservices and how microservices affect that. And then it's like, and then when we're running those in Kubernetes, what challenges and opportunities does that present?
Um, yeah, microservices is quite interesting, really, as an architectural approach. It's
Because it's
I
the
mean,
thing now, isn't it?
before
It is the thing.
it is the thing, but we've had service orientated architecture, right?
Yeah.
Where you compose your application domain or the functions in your application domain into services that provide certain functionality, right? So you would group functionality that sort of naturally fits together into a single service. Then you have a contract, and how you implement that on the back end is entirely up to you. But on the front end, you have a contract. So
So
you're
uh,
starting to distribute with service orientated architecture. You're starting
yeah.
to distribute your application now with microservices. Um, it's almost so rebranded, right?
So,
But
so, so
except
this is
we're
this so
talking
this is
about
yeah. So my take on this
smaller
one.
functional components.
Yeah. So my take on this one. Sorry to cut right in,
I know you go for it. Yeah.
but microservices are SOA, but SOA got itself a bad name because everyone basically got confused between a remote procedure call and a service, and so they wrote a whole load of web services, but just kept all their spaghetti kind of all interdependencies behind the scenes, different services all calling the same database and all that sort of stuff. And microservices actually, as a concept, was actually just sort of saying, cleaning that up to say, actually, if you're writing a service, that service needs a degree of independence. And what you don't do is you don't have a service here and a service here, and then they've got all sorts of interconnections behind the scenes. Is that a fair comment?
It is a fair comment. I see, for me, a microservice architecture, there's two principles to it.
Uh-huh.
There's one that those services have to be independently scalable, and then the second is that they're independently deployable. So microservice architecture. So was sort of going that way, and I get your point about some of the sort of challenges with Sarah, is the fact that systems have got bigger, generally speaking,
Yeah.
and when you have a monolithic application, your deployment unit is your application, and so it becomes very difficult to create an application that is scalable. But when you deploy, it doesn't have any downtime, if you see what I mean, because you're redeploying an entire application.
And this is back
Now
to
that
the seven outcomes as well, because when you've got a monolith and you have to redeploy the whole thing, well, that means you've got to retest the whole thing. And there's the downtime thing and losing availability, and then suddenly you're in this reams of testing, reams of all sorts of stuff, and then that makes it really expensive, so your costs shoot up. So
it does, yeah, and it's one of those things where because it is monolithic, you end up sort of, and releases are often quite painful. Therefore, you don't release as often, and
and then they become more painful.
don't get the rapidity of release that you're trying to achieve these days, and particularly for when you have a monolithic application where you probably have some core functions in there that are like really, really important to the application, and then you have a lot of ancillary functions that actually, they're not as sensitive in terms of the application working. If an ancillary function didn't work or went down for an hour because it was being upgraded, then it actually wouldn't affect the main flow of the core function of the application.
Yeah,
And
sometimes you have like offline number crunching or statistical gathering or that sort of stuff, or you put stuff on a queue and it gets processed later.
exactly that. And if you're talking about deploying a monolithic application, unfortunately, all of those sorts of things go with it. And so you start to break it up, and breaking it up into much smaller, discrete functions is a natural progression from going from monolithic all the way down to creating these sort of microservices that are independently deployable, which means that you can, the provided you've got the right, it's sitting on the right platform. You can, in theory, upgrade those without losing any downtime. And ancillary functions are all broken out, and because each microservice is independently deployable, you might decide that actually it's okay for this function to not be working for 15 minutes while it's being upgraded, or whatever it is.
But having said, and then bringing the Kubernetes in, what the Kubernetes allows you to do is to, it's quite an easy thing, easy in my world by just saying, Paul, do this, but it means that actually you can make those small units, and you can also have deployment strategies that mean that you can actually spin up your new one alongside your old one and then switch over and all that sort of thing. So.
You can, obviously there's some architectural challenges for, if you're creating a scalable service, then you're generally talking replicas, so you need to run multiple replicas. Now in the old days it was like web farms, where you would have your web
rolling deployments across a web farm and that sort of stuff.
Exactly, and it's the same thing really, but at a microservice level, and those microservices tend to be network addressable programs, okay, but you can create them in a you can deploy more than one instance of those, effectively replicas on a cluster, and then have rolling upgrades or having blue-green type deployments and so on to achieve higher availability, more scalable services, an independent microservice level. But the nice thing about a lot of these strategies is rollback. So if things don't work, then you can roll back, particularly blue-green, right? So where you deploy a new version of the application side by side, or a service side by side, you switch over, things don't work, you switch back again, and hope your customers haven't noticed in the process. But
or even if a few of them have, that you've at least got it. You've at least got it back as quickly as possible.
Exactly. So yes, there's. Obviously that tracing and tracing login doesn't really. We sort of veered off a bit, but we're talking about availability and scalability. But you can imagine if you've got multiple replicas. Let's say you've got 20 replicas of a microservice. Each one of those has to log. Because you might, so even if you're just talking about that one microservice and one fails, is that an underlying problem that actually could affect all of them? But you still need to get the logs off.
But not only that, you talk about the ability to roll back. But it's if you're not logging, how do you know something's not working? It comes back to that exact thing, doesn't it? Because you do this blue-green deployment or whatever, and I'll roll it back if it doesn't work, but how do you know if it's working or not? You only know if it's working because you've got the diagnostics in there.
True. Obviously, when you call the service, if it comes back with an error, then you'll know. But it's you still need. Ideally, when you if you were doing a blue-green deployment and you deploy a new version of the application, you wouldn't necessarily make it live yet. What you would do is you would smoke test it. And smoke test it and make sure that it's working, but you still, if it doesn't work, well, you don't want to switch over. But if it doesn't work, well, why? That's when you need to start looking at logs.
And so Kubernetes, Docker, Kubernetes. What particular opportunities and challenges does that present? Because you can go on the Docker website and look at building a container, and within half an hour, you can build your first container, deploy it into a Docker registry, and give yourself a pat on the back. But actually, the step from making that container into a production runnable, service is actually, there's a lot in there, isn't there?
There is, and I suspect that we're probably going to cover that sort of.
Yeah, that's
another
coming in.
But when you talk about complexity, then that that comes with, if you start talking microservice architectures where every microservice is deployed, is available in a container to be run on a cluster, you get density on clusters. So you can run many, many, many instances of microservices or containers on an individual node in a cluster, which is a machine. You imagine that if you've got tens of, if not hundreds of microservices on a single machine, and you've got multiple machines in your cluster, and things go wrong, then you're tracing, your tracing and logging strategy really has to come into its own, because how do you get that information off the clusters so that you can actually try and understand what's going on with your application, so you can then diagnose, and if there's fixes that need to be made, you can then rapidly fix the problem, push it out through your continuous integration service, get it regression tested, and then pushed out to your cluster in a rolling upgrade, or in almost a seamless upgrade that no one notices, but you fix the problem. But it starts with root cause analysis. So how do you need to understand what's happened in order to be able to fix that issue. And so when you get to clusters, the problem becomes a lot bigger. But there are tools and there are techniques that have been many people have been working on this problem in the industry, and there are a lot of tools and technologies that have sprung up to solve these issues. We particularly use, because
that's a good lead into what we're on next, isn't it?
Well, that's true.
Which is what are we actually doing? What is the stack? Doing?
So it's I think it's pretty standard. You have a first off, it's about collecting logs. So if you're on a cluster, you're running a container instance on that cluster, and your component in that container is logging, and is logging to standard out typically.
And when we talk about a container, for those people that aren't in the world of containers, a container is just really almost just lets you run. It lets you isolate an application. It's like a mini. You can run many containers on a machine, but each of them is isolated from each other. So it's like it feels like you've got an isolated machine that just runs one thing. And it's like a little virtualized process. And you could be running a daemon, or you could be running an API.
Yeah, as far as that process is concerned, that the primary process that runs in a container, it feels like it's in its own environment, almost like it has its own OS. So you're almost like virtualizing in an OS with a container, as opposed to virtualizing a machine with more the sort of VM level.
Yeah, and typically in a container, you've just got that one. You've got that one process running.
Typically. So if you're talking about a microservice, say just like a REST style service, then that would be the web server. That is running, that you can then obviously communicate with.
Okay, so we're at this. So we've got our little application. Maybe it's an API running in a container, and that needs to log. So that's our starting point, isn't it?
So that is the starting point. So you're logging out to standard out, and you're producing log entries. Those logs need to be collected.
Yeah.
So typically on a node in the cluster, you would have a log collector, and that log collector would be looking at or collecting the logs for every container running on that node.
Yeah.
So log collection is almost the first part. How do you collect multiple logs? And then there's log parsing. So how do I make sense of the log entries that are being output by these services? Now, there are a couple of ways really that you can do this. I mean, typically you would printf style debugging, right? You would write out a a log entry, and in that log entry you might decide that actually, you know what, just having a message in there is, it doesn't make. I mean, the message is good, but you need other information,
Yeah,
like you need to know the date and time when that occurred, and you might need to print out some values of control structures in your program, or values of certain variables and things like that. So you might start to print this out in your log entry. And so one of the parsing process of a log collector can actually make sense of that log entry and produce like a little packet that breaks that log entry down.
yeah. So this is one of the things that we had in the original article. Is one of the rules is log structured data, because you can, because you, like you say, it isn't just a message something went wrong. It's you've got all these different parameters.
There's metadata associated with that.
There's metadata associated, which is, like you say, the date and time. Usually there will be, what application is it?
Yes.
There's usually some sort of informational message, but there may be some numerical values. There may be a criticality associated with it. And you may tag on other important application data. So you generally have a packet of stuff, and that has to all be readable, and we make that readable by making it structured.
Exactly. So that's the next step. So the first step is that you write a text log entry out, and you might encode all of that information in that log entry, and so therefore your log collector really needs to parse that entry in order to be able to extract the bits out of it. And then you get to the structured logging, which is what you're talking about, where you accept the fact that the core is the message that you want to get over when you're writing that log entry, but there's lots of metadata. So you're right. There's a date and time. There might obviously the name of the service that emitted the log entry. You might have the operation within that service that actually where that failed. There might be some contents of variables and so on, the severity of the message. All of this is metadata to enrich that log entry. But the core is the log message itself. But instead of actually writing out to standard out a line of text that is human readable, what you could do is write out let's say a JSON packet.
Mm-hmm.
I mean, it's still somewhat human readable, right? But it's not.
But it's also machine parsable.
But it's much more machine parsable. And so structured logging effectively takes this approach where you have like a sort of a log entry, which has the core message, and then has a whole load of key value pairs as metadata associated with that message. Now, the great thing about this is that once you've collected all of those logs and you've parsed them, you then need to ship those logs somewhere for that information to be stored. And so for us in terms of log collection, we use FluentBit, which is a lightweight FluentD, but it's basically a log collector and parser.
Yeah. So and just for everyone, that's the benefit of everyone that isn't familiar with FluentD. FluentD is one of the industry standards now, isn't it?
Yeah.
But it kind of does everything, whereas for containers you don't
as well. But we
because you got the ELK stack, and Logstash was the L of the ELK stack, whereas FluentD has kind of superseded it a bit. It's for a lot of people.
EFK stack, yeah.
It's the EFK stack, but FluentD is like a whole Swiss Army knife with tons of stuff. But for containers, you don't need 90% of it. So there's FluentBit, that's the cut down one.
Which is really the bit that runs. So we use FluentBit that runs on a node in its own container as well, and it collects the logs from all of the other containers and then ships them to Elasticsearch, and it ships them as index documents. So when we talk about structured logging, the metadata become indexable fields that allow you to search against those entries. So if you wanted to search, I don't know, an error occurred and it was sort of roughly at midday on a particular day, you might go, well, actually, I want to limit my search to 10 minutes either side.
And that's what makes Elasticsearch so powerful, because
Exactly, yeah.
it's really good at that kind of searching stuff, isn't it?
It's basically a big search engine, yeah.
Yeah, it's like it's like have your own search engine.
Exactly, and therefore very useful for searching structured log entries that have been emitted by lots and lots of different microservices across different machines. We talk about metadata. The machine that the log entry was emitted on is also another important piece of information, because it might be that the node itself is bad, and you can deal with that in Kubernetes, but the node itself might have problems, and so you need to be able to understand enough about what's going on. It could be the thing that's caused the problem is maybe the machine's overloaded.
Yeah.
So maybe you're capturing as well some metrics about what was going on the machine at the time, CPU, memory, that sort of thing. But you need to ship the logs somewhere. Now, what you can do is so you can use Fluent D in an aggregator mode, where instead of shipping your logs from Fluent Bit, which is collecting logs on an individual node, directly to Elasticsearch, what you can do is ship them to a Fluent D aggregator, and then get Fluent D then to pass them on.
So the benefits of this are what? So that you only have, so you've got fewer things connecting to your Elasticsearch, is it?
Well, you might have. So if you're running multiple clusters, so as we do, so you've got a test environment, you've got a staging environment, you've got a production environment. Maybe you've got more than one production environment because you're geo-distributed.
Yeah, so if you've got multiple data centers, you've got a cluster in each.
Yeah, and you actually, so rather than having an Elasticsearch instance per cluster, maybe what you want to do is to shift all of your logs into a special cluster for log analytics. So you might have a central cluster that you want all of the aggregators to ship all the logs to, so you can actually get a view across all of your clusters, as opposed to having a view per cluster. So that's where you might start to get a bit more fancy, I guess, with your log collection and aggregation and shipping strategy. But I mean, obviously, all of that's dependent on an individual use case. But I mean, you could take that approach. But once you've got it into Elasticsearch, then you're into, it's been indexed. You're into a search engine where it's really designed to allow you to search your logs, or to search the information within it. In our case, searching the logs, so you can start to do log analytics, which is fantastic. And so, Elasticsearch is just a search engine based on Lucene.
Yeah.
You really need an interface, which is where the K comes from in the ELK or the EFK stack. You really need an interface to make it easy for you to interface with all of that data, and so Kibana is the natural technology to then do log analytics effectively.
And Kibana is actually a product from Elasticsearch, isn't it?
It is, yeah.
And that's the like you say, that's the window into it that helps you make sense of all that data.
It does, and so and if you've gotten this far, then this is great. You've got you've got an interface where you can look at all of your log entries. Fantastic, brilliant. Okay, so now how do I find?
Yeah.
No, something's gone wrong in the application. Like, how do I find the related log entries to the thing that's gone wrong? And that's the next challenge is you're creating these structured log entries, but you've got to have enough metadata to allow you to relate entries to each other. And so one of the fields that you would probably add is some form of trace ID that spans across service boundaries
Yeah.
that you associate with an individual request. So if you've got a website and a customer on your website clicks a button, so I don't know, checkout.
Yeah.
Now that button click there's going to be probably a whole bunch of things that's going to happen on the back end, but it's all
Yes.
initiated by somebody clicking a button on a website.
So it's one click, but there's a process that goes on, and that might be calculate the shipping and check that the stock's actually there, or confirm the stock, or and you call a whole load of these steps.
Exactly. So before you get to the next page, there's a whole bunch of stuff that's whirring away on the back end, and so if that were to fail, how do you relate that back to that original button click? And so you would use like a trace ID. You would assign a unique trace ID to that button click. So and you would make sure that trace ID would traverse all service boundaries through the call stack effectively, and make sure that every log entry that is associated with that request is logged with that trace ID.
And there's an interesting thing here in that, I mean, we've worked with integration for a long time. We back in the day, BizTalk and all that. But the principles of integration are the same. The tools you use are different. But one of the things that's a truism about integration is that usually the component that's doing the complaining often isn't the one that's actually got the problem. Because that's dead or somewhere. Yeah. So there can be, so one component is saying, I've tried to do this and the bit I'm talking to isn't answering, and I'm gonna send the message to say there's an error.
Yeah.
But actually the bit to diagnose actually isn't in that one, it's somewhere else.
Yeah.
And so what you're saying is that by everything having the same identifier, if you go to that component that's raised a complaint and you get the ID off that to say this is the error, this is the correlation ID, you then search on that correlation ID, and that gives you everything to do, from someone clicking on the button in the UI through to all these other steps, and it gives you all of that. And one of them will be the bit that you saw, which raised the complaint, but then you can try and drill into what's actually happened in the bit that isn't actually working.
Yeah, correlation ID is another good name for it. It's I tend to bounce between the two sometimes, actually. But you're absolutely right. You need to be able to correlate, which is the key word, correlate what would appear to be unrelated trace entries to each other, so you can get a feel for the flow. Obviously, timestamps become really important because you're going to have to order by timestamps, as high resolution timestamps as possible. But of course, if you're talking about clusters, it's likely that request has been processed on different machines, and timestamps can be sometimes unreliable. Obviously,
you can get clock drift, can't you?
Yeah. So then, and this is particularly important with audit, but you have to start thinking about time synchronization and stuff. I mean, it's there are solutions out there for this, and but it becomes important when you're talking, a multi-node cluster. Clock drift is not just for security and audit. Obviously, it's for being able to order your log entries so you can make sense of a flow through the system. But as soon as you start to tag all of your log entries with a trace ID which has been generated from the user action at the front end, or if you've got a more of a daemon style process in your back end and it's clicking off on every period, that it's also generating its own trace IDs because it's the initiator of the action.
Yeah.
Then being able to relate all of those different trace IDs in as part of that call stack, all the service call stack, becomes really important. And then you can search for that then.
Just as a kind of an illustration in practical terms. So okay, you've got something that initiates this, and you effectively make loads of calls to loads of different APIs. in actual practical terms, how do you pass that correlation or that trace identifier across?
It depends on the technology. So
Or how
obviously,
would we do it? Because
across
we're
service
talking,
boundaries, if you use an HTTP, then it just goes into an
this goes custom header.
HTTP header, goes
Yeah.
into a custom header. And when you receive it on the service side, a lot of the web frameworks these days have what they call middleware components that run before the service itself gets the request. So you can have middleware components that do things like checking there's an authorization header in there and a valid bearer token and so on for security. Another one will be, does it have a trace ID in the header? If it does, great. I'll use that to then every log entry that's raised within the program call stack for that request is logged with that trace ID. The programming language that you use becomes, and maybe the runtime that you use, you have to figure out a way of how do I pass that trace ID?
They've all got their own slight flavour of how that.
They've all got their own side flavor. But effectively, you've got to make sure that trace ID can flow through the program. And if you're multi-threaded, it's got to flow across threads. And then if you make calls out of the system, so let's say you're making another HTTP call, then you pop that in the header, so that the next component can use it. If it's, there's a lot of
so there's actually quite a lot of discipline in doing that.
There is a lot of discipline, yeah.
Because it's something
you're talking gRPC.
Yeah.
You need to think about how do I pass it there. If you're going across, so let's say queuing. So you're queuing. So instead of it being a synchronous call through like a web service, you're going to make you loosely coupled application. So you pop a message on a queue, and some downstream component will pick that message off at some point, and then process that message. It might not be related directly to the synchronous call that the users made, but it's all related to directly in terms of that synchronous.
It's all off that initiating.
It's still all related.
That thing that initiated right at the start, it's all a chain of events that come, or events is an overloaded term. It's all as a consequence of that initiation.
It is, and so you want to preserve it, and so you have to think about how do I preserve it in a queue message, and again depends on the technology.
Yeah,
a lot of queuing messages will allow you to attach metadata to the queue message, and you just got to, when you receive the message, you just got to be aware that actually this message might have some metadata that I'm interested in, like a trace ID. So it's you have to be disciplined, but you have to be aware that you need to find a way of being able to send this additional data to the request.
But the way that we solve this is that effectively we create patterns for it.
Pretty much, yeah.
And that we say, okay, when we're making an API, we use this pattern to do this, and when we're doing a queue message, we use this pattern, and then that kind of captures that best practice, and then we know that as long as you've used the pattern, it's going to kind of be okay.
Yeah, and you enforce those patterns through code reviews.
Yeah.
So you make sure that people are implementing it correctly. But it's a lot of it's development discipline, right?
Discipline, and because you've got it's the age-old thing, isn't it? You can pick up a certain amount of code review, or you can pick up a certain amount through a static analysis. So is your code stylistically correct? Does it compile? Does it conform to a certain set of rules? But there's always a hard thing, and this is a whole subject for another day, which is how do you enforce design intent? And that's kind of that's what we're talking about there, isn't it?
Yeah, exactly that. And that's it is a challenge, but people being aware of how important, particularly the subject we're talking about here, how important it is, and you quite often as a developer you realize that is really important, because when you're creating a program, you're adding some functionality and it doesn't quite work out. you need the login yourself to be able to finish your task, to make sure that it is working. And obviously you're going to write tests and so on.
And there's another thing,
you're going to need logs.
But another thing that both you and I have done is that in our past life, we've been the one that's there at 1 in the morning trying to figure out
Yeah,
why something's not working.
yeah,
And if you've been on like a client site when there's a system that's cost tens of millions of pounds, and you're there at 1 in the morning, and there's a whole bunch of people sat over your shoulder saying, "Why isn't this working?" If you've ever
yeah.
been in that situation, you kind of know that you've got to get this stuff in there because
You understand the value.
you understand the value.
Yeah,
Yeah.
yeah. Fantastic.
Okay, so we talked there about, so that's how we get application log stuff, which is correlating them, so we've got the whole trace of what's happened for diagnosis stuff. Um, Now, how things are performing is slightly different. That's a slightly different challenge, isn't it? Should we talk about that a little bit?
Yeah, I mean
Because it's
it's
related,
slightly
but it's
it's slightly
yeah,
different, but it is related. I mean, it's information that's going to help you diagnose issues. How applications are performing tends to be a bit more non-functional in nature. So you're looking at, how does my application perform under load,
yeah,
and how can I understand whether I have enough resources for my application in my environment, or am I pushing my machines too hard that I'm staring a future problem right in the face.
because I mean,
Uh,
there's some really important kind of things. So let's just kind of drill into this a bit because you've kind of got system resource questions, haven't you? Which is how much memory have I got? How much CPU have I got? How much disk space have I got left? And all that sort of thing. And then you've also got the application things like how long is this application taking to respond?
hmm,
But then one of the things that's really kind of powerful overlaying that is if you can identify trends in these, because
yeah,
you start most of the time you deploy an application, it works fine, everyone goes away, pats themselves on the back, and then at some point later the application stops working. And actually, if you'd only been looking at the right trend, you could have predicted 6 days ago or 6 months ago when you were going to hit a crunch time. And so
yeah.
that's what we're trying to get with this performance data. That's what we're trying to achieve here. Is it's not just does it work right now, but we're also trying to plot ahead to say what do we need to do to make sure that it's going to continue to work.
See, back in the old day, and in the IBM mainframe days, it
Again,
used
disclaimer before my time.
yeah, there used to be capacity planning.
Yeah,
Capacity planning was a function that you did.
because
Um,
because it's a serious thing.
it is. I mean, it's unlike we're really spoiled these days with the cloud and on-demand provisioning of almost unlimited resources, right? Or unlimited from your perspective.
It
Um,
is unlimited, but it comes with a cost.
it does come with a cost,
So
but
you
you
can like
imagine though, if you don't do capacity planning
yeah,
and you're running on IBM mainframes,
yeah,
the lead time to buy a bit of hardware and get that installed into an environment which is specialized, water cooled, and so on. It's you have to do the capacity planning exercise in order to be able to think about
yeah, because
what is it you're going to
it
need in
might be 2 or
6 months'
3
time.
months. Yeah, it might be 2 or 3 months before you can get something in.
Exactly. Whereas obviously on demand provisioning in the cloud, I mean, you still have to predict, but you can react a lot quicker
Yeah,
to resource needs.
and so you can go closer. You can go a lot closer to the wire because you can just. But the both ways. I mean, understanding capacity and understanding where you're going gives you an understanding of your cost, which is part of our 7 outcomes is cost optimizing. So although it might seem like a magic bullet in the cloud to say, hey, let's have more resources, it
Yeah,
doesn't
you're
come for free.
absolutely right. It does come with the cost. And yeah, cost management is, particularly solutions running in the cloud. Cost management is really important. So I mean, if we talk about metrics, so we
Yeah,
talk about performance and so on, but it's really metrics. We're trying to gather metrics about the environment that the application is running in, some metrics about the application itself. How is the application performing?
yeah,
Um, but there's also other metrics that we want to gather. So the real user metrics from
Yeah.
we want to gather how are people using our service, how are people using our website, and those are all metrics. So being able to gather those metrics and then analyze them through some tool is also really important. Now, a lot of that you can still do through the EFK stack or the ALK stack. We do it slightly differently. So we do eventually push metrics into Elasticsearch, but we go via Prometheus.
Uh-huh.
And Prometheus is effectively like a time series database.
So it's more specialized for this sort
It's
of thing.
more specialized for gathering metric type data, and all of those different types of metrics that we've been talking about all get pushed through Prometheus. And then there's another again, Prometheus is just effectively a database and a metrics collector, but you need an interface. I mean, Prometheus does give you a basic interface, but if I want to have a rich way of being able to slice and dice,
Yeah, and a lot of this stuff is charty and graphs over time and all that sort of thing.
Yeah, pretty much mostly. There's always a chart involved, right?
Yeah.
You see any sort of performance test documents, they all have charts in them. So you need to be able to chart the data, and for that we use Grafana. Grafana is a fantastic technology for creating dashboards of time series type data, and it natively plugs into Prometheus. It will also plug into Elasticsearch as well, but it natively plugs into Prometheus. And so metrics are a funny thing, really, because there's an immediacy to the information that you want to look at. So, what's my CPU doing right now on my nodes? And so there's also the real-time metrics. So we use Prometheus for a lot of that, for getting more immediate information about what's going on. But we also push that data then from Prometheus into Elasticsearch, because when you're not really worried about what's going on right now, you might then want to look at, okay, I want to do some historical analysis. So for things like capacity planning, so I want to be able to project forward, or real user metrics. Maybe I want to project forward my daily active users from where I started to where I am now, and what's the trend. So we can push a lot of the all of the data into Elasticsearch, and then look at doing much more sort of historical analysis over a wider data set than you would necessarily put through Prometheus when you're looking at sort of real-time metrics.
Because I mean, one of the things that
we use it anyway.
Yeah, because one of the things we're looking at here is that there's, when we're talking about this data, there's an awful lot of it, and so for things to happen in real time, you've kind of got to limit it to, you can't capture humongous amounts of data since the dawn of time and then expect it to be really good at real time. So you've got to kind of limit your, so the fast stuff, you've got to kind of at least limit how much of it you've got, which is what we're talking about with Prometheus. But then you can move it into something that's maybe a bit better at handling size of data, but not necessarily always as fast, and that's where we can kind of push it into Elasticsearch.
Yeah, absolutely. And they're all tools just to help us to really understand what's going on. I mean, that's obviously what people use them for, but the sort of after the fact analytics is really, really important. It becomes very difficult to do your job really if you can't do that. So that's why logging and tracing, logging diagnostic messages, but also logging metrics. That's why it's so fundamental to an application, big or small. It's so fundamental to being able to do these types of root cause analysis, log analytics, the analytics of capacity, and analytics of how is my service doing in the wider world. What daily active users, all of those different types of sort of customer metrics that become really important for how you commercial strategies and so on. And it all starts with the fundamental.
It all starts with capturing the stuff.
How do we get this information out of the system?
Yeah.
So yeah, lots of effort goes into it, but obviously lots of benefit for when you get it right.
Yeah, and it's something that, I mean, I think again, going back a little bit, we used to do a lot of stuff on Windows servers where you'd write to application event logs, and you kind of think, well, that's okay, we've kind of done our bit there because you can look at the event logs. But there is a problem with that because those stay on the machines, and then if one of those machines crashes and you lose it, you can't see those logs. So it's that whole thing of externalizing them.
Yeah,
is really important. And then, but the big change is when we move to cloud. Then because in cloud you really do get a machine, a machine can really disappear. And another one pops up to replace it, but then anything that you're relying on being on that machine, you just cannot rely on it in the cloud. You've got it. So that was where the mindset shifted into making sure all this is externalized. And then containers is again, it's just it's another extension of that process, isn't it? Because you can't rely on storing something on the operating system of a container.
No,
because these things get created.
Fairly ephemeral, aren't they?
They're ephemeral.
Yeah, they come and go. Particularly, if it's just simply a case of shifting, in Kubernetes, if you're shifting pods around, containers around, because you've got one machine which has suddenly got low resources, and then pods move and so on. Then suddenly you were logging on that machine once, and now you're suddenly logging over on this machine.
Yeah, and if you've externalized it all and captured it in a central store, doesn't matter, does it?
It doesn't matter. And if you're capturing that metadata, then you can see that that's what happened.
Yeah.
We were logging on this, for that replica, we were logging on this machine, we're now logging on this machine. And you've probably got other metrics to support the fact that actually maybe that node disappeared. Maybe that node failed and another node came up, and that replica was then brought up on that new node. So you start to get the evidence to support that these things have occurred. It's all good stuff.
It's all good stuff. So I think we've covered most of what I think we were going to cover. Is there any particular big, any other particular big pointers that you think would help people in this area, or any particular tools that we haven't mentioned that they should be looking at, or any particular knowledge or resources they should go to?
No, I don't think so. I think we've covered off the basics. Is so creating logs. So when you log in an application, typically you're going to use some sort of tracing library or structured log library to actually create the log entries within the application. And if you're running in containers on a Linux box, it's almost certainly going to go to standard out. You've got log collection. So we're using FluentBit. You could use Logstash there. Log collection, parsing, and then shipping. You can ship to an aggregator, or you can ship straight to your search engine. We ship to Elasticsearch. Then you've got to have a view on that data. How do you make sense of that data? So Kibana for log analytics and Grafana for metric time series type data. We also use Prometheus specifically for metric collection and for real-time viewing. And then we just plug the data from Prometheus for more historical purposes. We then plug that into Elasticsearch. You can run Elasticsearch on the cluster that your other microservices are running on, or you could decide that you're actually going to have some sort of centralized cluster for storing all the logs. for collecting logs across multiple clusters, particularly if you're geo-distributed. I think that pretty much, in terms of the sort of tool set,
Yeah.
I think that pretty much covers it. I mean, we haven't talked about archiving, but the archiving has to be a strategy, right? You can't have. I mean, I know
You can't have
right.
you can't have endlessly growing data forever. So you have to sort of say,
you've got to think at some point.
yeah.
Do I need to have data from 15 years ago?
And if you do have it,
quick storage.
yeah, it's like, because it's storage tiers, isn't it? So it's like, okay, I need this fast, but the stuff from 15 years ago can be in cold storage somewhere.
Exactly. You can sort of take it offline effectively. You can still store it, but put it on really, really cheap storage. Then there's obviously delete, purge.
Yeah.
So you might decide that actually maybe 15 years is a bit too long. Is it really going to be relevant?
But if you've got, but like if you're archiving on, like, let's say, a month at a time, so you've got a month's worth in Prometheus, and then you've got a year's worth in Elasticsearch, and then every month you take the oldest month and put that into cold storage. Purging becomes really easy because you just kill the oldest month.
You kill the oldest month very, very,
and that becomes really easy. So if you've already done the archiving strategy right, the purge part actually becomes quite easy.
And it's a rolling process.
Yeah.
And you might decide that actually, I'm going to keep 3 years worth of analytical data just there, just in case we want to go and search it. But otherwise, anything older than 3 years, just purge. So again, every environment's different. I mean, we've worked on financial systems where
7 years.
The requirement to keep it 7 years. So every environment is going to be different as to how much data how much data, how long you want to keep it for. Data does get stale though, right? So how relevant is data 3 years old to data that's 6 months old? Probably not that relevant unless there is a compliance.
Yeah. Which in things like financial services, that's
exactly, you might need
that's
to.
That's why you get some of that, because you need. Yeah, because if a year later, and this does happen, like particularly for things like businesses, they do their end of year accounts and they say, "What's this payment?" And you will get a query for, or someone has a tax investigation, and then suddenly 4 years later, someone says, "What was that payment?" And so there are real world scenarios where you need this stuff, but for most people for most applications it's relatively, like say 6 months is relatively old. You might want to look at trends over 3 months, but it depends. It just depends on what the scenario you're in, doesn't it?
Exactly. And so your cost, particularly storage costs and costs in terms of compute consumption, they're at the sharp end of the age of the data, because that's where you want your speed of access, querying, and then as it gets older, then you allow or expect the fact that it's not necessarily going to be on the fastest disk. Queries are going to probably take a bit longer, but if you're looking at historical analysis, you're not going to be looking for sub-second query response times. Why would you?
Yeah.
Set the query off and then go and have a cup of coffee, right?
Yeah, because no customer is going to make you're not affecting a customer's decision to do one thing or the other based on data that was 6 years old.
Yeah, absolutely.
But they might be doing it based on how much stock have I got, or can I get this quickly, which is all your timely data.
Yeah.
But that is a whole big subject. Probably something that will come up in the future.
I think we've touched on a lot of big subjects that we've it's. I mean, tracing logging itself is a reasonably big topic, but it does touch on so many other things, which I'm sure we will cover in other episodes.
We will. So on that note, on that bombshell, I think we'll wrap up for today. So thanks a lot, Paul. I hope everyone that is watching really kind of appreciates the depth of knowledge that's gone into this, and and you sharing your experience. It's been really good. I mean, I'm working with you every day, and I've learned new stuff. So,
Well, that's good.
that's really good. So yeah, thanks a lot, Paul, and
Okay.
and I hope you enjoyed it. And we'll catch you next week for episode 2.